there we go. Okay, so inductive reasoning is really something you do all the time. We kind of train ourselves to do it from birth. I have a 10-month-old baby, and he uses inductive reasoning all the time. If he sees that when he steals the toy from his sister that she screams, and when he steals the ball from his sister she screams, and when he takes her piece of paper she screams, he knows that he can get a scream out of her just by taking something. Okay, and that is inductive reasoning, and he has already learned that. Okay, so that's exactly what inductive reasoning is. It's a process of reasoning where a rule is true because of specific cases. So here's an example. So the first part of in inductive reasoning is to make an observation of something happening over and over and over. So one example is you might go, oh, robins, they fly, and pelicans, they fly, and eagles, they fly. We have about 90, Josephine. And that's how many. And so that's the first step in inductive reasoning, is to look and go, this is happening. All of these things fly. All of these birds fly. Okay, after you've observed something happening, then you make a conjecture. Okay, and you think it's probably true because you've seen it. Yeah, I agree. You've seen it happen over and over again. Okay, so after noticing that all the birds that you've seen can fly, you might make the conjecture that all birds fly. Just like my son. He said, well, his conjecture was, if I take something from her, she's going to scream. Okay? And a lot of times your conjecture can be right. Sometimes the conjecture is not right. The way that we show a conjecture is incorrect or false is by giving a counterexample. Okay, so a counterexample is an example that proves a conjecture is false. Okay, and so in this case, I saw all of these birds, robins, pelicans, eagles, they're all flying. I made the conjecture that all birds can fly, which is not true. One counterexample to that is a penguin. Penguins can't fly, but they are a bird. Okay, so to get a counterexample, I had to find, since my conjecture was that all birds fly, I had to find a bird that couldn't fly. A penguin would be my counterexample. It's a bird that cannot fly. So I know my conjecture wasn't true. Okay, does that make sense as far as inductive reasoning? An ostrich, yes, an ostrich would be another counterexample to this statement. Yes. Okay, so again, inductive reasoning is something we do all the time. You observe something happening over and over again. You make a conjecture that that's going to happen all the time, and occasionally you're wrong. Sometimes there is a counterexample that proves your conjecture or your guess to be wrong. And that is what we're working with in Lesson 9. So here are the 3 steps for inductive reasoning. You first look for a pattern. Once you find the pattern, you make a conjecture. And then if it's false, you do that by finding a counterexample. Okay. So let's try some mathematical inductive reasoning. Patterns are one way in mathematics that we use inductive reasoning because we see something happening and we make a guess about it. So here's a pattern. What's the most probable next item in this pattern? So we go from 4, and then 9, 16, and 25. So first we need to figure out what is the pattern. What do 4, 9, 16, and 25? Can you think of anything that relates them? A lot of times we'll try to go, oh, maybe it's the difference, but between here there's 5. Between here there's 7. 9. Oh, that is almost a pattern. It is actually a pattern. The next one is 36. Okay, what would be the next one after 36? Okay, so that's where our pattern breaks down, because we were adding the next odd number each time, because this difference was 11. Okay, Okay, but if we tried to add 12 to this one, that puts us at what? Or 13, sorry. That puts us at 49. Good. And I'm surprised to find that pattern. That is not the pattern that I had planned to use when I came up with this question. Can anyone else see a different pattern other than going up by an odd number, the next odd number every time? Okay, the pattern I had intended to use was that these are the perfect squares. So this is 2 squared, then 9 is 3 squared, and 16 is 4 squared, and 25 is 5 squared. That's the one I meant to use, but apparently you also get that pattern by adding the next odd number every time. Huh. So either of those patterns worked because we were able to find the next number was 36 either way. So that's kind of cool. That's not the pattern that I observed, but it's the one that you guys found, and it was also true. Okay, complete this conjecture. The product of two even numbers is what? Okay, so when you're trying to find a conjecture, sometimes you might want to do some trials. Okay, so let's see, two even numbers. Let's do 2 as an even number and 6 as an even number. Product means to multiply. So what is 2 times 6? 12. Okay? So would I make the conjecture the product of two even numbers is 12? Would that make sense for all even numbers? No. Here's another pair of even numbers. 4 and 8, they're both even. 4 times 8 gives me 32. You're right, 32. 4 times 8 gives me 32. Okay? But notice I can't use that the product of two even numbers is 32 because it's not always going to be 32. Let's try another pair. 12 times 10. Oh, good job, Josephine. Would be 120. And so Josephine's conjecture is that the product of two even numbers is even. It worked with the 3, that's a 20, sorry, my pen gave out on the way around. Okay, so we did a few trials to see what happened and formed a conjecture. Now, we may go through doing, good job, we may go through doing these trials and come up with a conjecture, and then someone may find a counterexample to prove it's false. But right now we're working on, first of all, just making a conjecture, and this looks like a valid conjecture to me. The product of two even numbers is even. Alright, what would be the next item in this pattern? January, April, July? What do you think? October. Okay, someone thinks October. What might be next? What? Everybody agree? Okay, and how did you get that? Why do you think the next one is going to be October? Every third month. Okay, so notice we have January, February, March, then we write down April, May, June, July, August, September, October. I think that you're probably right. The next item in that pattern would be October. Every third month was their pattern.